You know, we're surrounded by these invisible forces that literally run our world. From the smartphone in your pocket to the lights in your ceiling, it's all powered by this secret partnership between two of nature's biggest players. So let's peel back the curtain and see how it all works.
I mean, think about it for a second. One of them spins the blades on a fan, and the other lets doctors see inside your brain. On the surface, they couldn't be more different, but it turns out they share a secret origin story, a hidden link that completely changed the course of human history.
And here's the best part. We stumbled upon this world-changing principle almost entirely by accident. This wasn't some grand, planned-out experiment. It was just a simple, unexpected observation in a university lecture.
And that one little observation, well, it threw the doors wide open to understanding one of electricity's greatest hidden talents, its incredible ability to create magnetism. Okay, picture this. It's 1820. A physicist named Hans Christian Ørsted is giving a demonstration. He switches on an electric current, and he just happens to notice that the needle on a nearby compass suddenly twitches and points to the wire. That was it. That was the first real proof that electricity and magnetism weren't two different things at all, but really just two sides of the very same coin.
So here's the big takeaway from that moment. A charge that's just sitting still, sure, it has an electric field. But the moment that charge starts to move, the moment it becomes a current flowing through a wire, bam, it creates something totally new, a magnetic field that swirls around it.
And you can really see this is a brand new kind of force, completely different from static electricity. Get this, if you run two wires next to each other and the current is flowing in the same direction, the wires will actually pull toward each other. They attract. But if you reverse the current in one of them, they push apart. That's the magnetic force in action, clear as day.
Okay, so moving charges create magnetic fields. Fair enough. But what happens when you take a moving charge and throw it into a magnetic field that's already there? Well, as it turns out, there are some very specific and kind of strange rules that control that whole interaction. Physicists have a name for this, of course. They call it the Lorentz force. It's basically the master equation that tells you exactly how a particle is going to get pushed around by electric and magnetic fields. And it's the magnetic part of that force where things get really, really cool.
And there's actually a super simple trick to figure out which way that push is going to go. It's called the right-hand rule. Seriously, you can try it right now. Point your thumb in the direction the particle is moving. Then, point your fingers in the direction of the magnetic field. The force? It pushes straight out of your palm. It's a handy little trick for predicting an invisible push.
Now, here's the weirdest and probably the most important part of this whole thing. The force never pushes the particle forward, and it never pulls it backward. It always pushes it sideways, perfectly perpendicular to the direction it's already traveling.
I mean, just let that sink in for a second. A force that cannot speed you up or slow you down. All it can do is make you turn. So if you're a charged particle flying through a magnetic field, this constant sideways push forces you to travel in a perfect circle. And that tendency to spin is the secret we've learned to harness.
So, let's connect the dots. How do we go from this weird physics rule about tiny particles spinning in circles to the massive technologies that power our lives? How do we put these spinning charges to work for us? Right, this is the big engineering problem, isn't it? It's one thing to make a single electron spin around, but it's another thing entirely to spin a drive shaft. So how do you scale up that tiny circular force into powerful continuous rotation?
The brilliant solution is a loop of wire. When you send a current through it, the magnetic field pushes up on one side of the loop and down on the other. And because these forces are opposing each other, they don't just shove the loop, they create a powerful twist, a turning force. That's what we call torque.
And here's the really clever part. Just as the loop is about to complete its turn, a little device called a commutator instantly reverses the direction of the current. This flips the forces, which gives the loop another powerful push in the same direction. Do this over and over and over, thousands of times a minute, and you get continuous rotation, the very thing that drives our world.
But this amazing principle of bending the path of charged particles, it goes so far beyond just motors. We've used this exact same fundamental rule to unlock the secrets of the atom and to completely revolutionize medicine.
Take a particle accelerator, like a cyclotron. It uses an enormous magnetic field to trap particles in an ever-widening spiral path. And with every single loop, an electric field gives them a little kick of energy, pushing them faster and faster until they're moving at nearly the speed of light. We use these for everything from fundamental research to even some cancer treatments.
And this exact same principle is at the core of one of the most important medical tools we have, the MRI. At its heart, an MRI machine is really just a giant, unbelievably powerful electromagnet.
So a typical MRI machine you'd find at a hospital generates a magnetic field of about 1.5 Tesla. Now, that number probably doesn't mean a whole lot to you on its own, right? So let's put it into perspective. The entire planet Earth has a magnetic field. It's what protects us from solar radiation and makes our compasses work. So how strong do you think that is compared to an MRI?
Well, the Earth's magnetic field clocks in at about 0.000036 Tesla. That means the magnet inside a standard MRI is over 40,000 times stronger than the magnetic field of our entire planet. That's the kind of invisible power we're wielding to see inside our own bodies.
And it just brings this whole story full circle, doesn't it? It all started with a compass needle twitching in a classroom, a total accident. And through decades of science and engineering, we turned that one simple rule, that magnetism pushes moving charges sideways, into a technology that can map the human brain without ever making a cut.
You know, this incredible partnership between electricity and magnetism has fundamentally changed human civilization. It really makes you wonder, what other secret handshakes, what other invisible forces are still out there, hiding in plain sight, just waiting for another accidental discovery to change the world all over again?